Okay, so with apologies to David Letterman, I want to tell you the top 10 mistakes that I think you guys mostly make. And so the purpose of this talk is to get you to stop making them. So here we go. Blunder number one. You should be thinking about moving all of your data out of this building and put it on the public cloud. Or if you are worried about the public cloud, buy a private cloud from one of the cloud vendors. Why do I say that? I want to tell you two quick vignettes. Vignette number one is from James Hamilton, who works for Amazon. He claims, in my opinion, completely correctly, that he can stand up a server for 25% of your cost. So they have a 75% cost advantage relative to you, and there are lots of good reasons for that. One is they're deploying servers by the millions, you're deploying them by the tens of thousands. They're putting servers in the Columbia River Valley, you're putting them upstairs. They're way further up the cost curve and are making huge economies of scale. Second thing, which is I think even more persuasive, is a vignette from David DeWitt, who until recently was the head of the Microsoft Jim Gray Systems Lab. So here is the technology that Azure was deploying as of 2 years ago, and I haven't heard that it changed. So here's what they were doing 2 years ago when they put up a data center. It's a shipping container. Well, it's a collection of shipping containers in a parking lot. Power in, chilled water in, internet in, otherwise sealed. Stick them, line them up in a big parking lot. Roof and walls are optional. They're only there if you need them for security. So that's the technology they're using. Compare that with whatever you're doing, which is raised flooring in this building. Or maybe you've moved the raised flooring to Secaucus, but I doubt if many of you are using shipping containers for your on-prem data centers. And so the other guys are clearly way up the cost curve relative to you. Also, if you move to the public cloud, you get elasticity. So you want to run your end-of-month numbers, you need 1,000 servers. On the 15th of the month, you need 10 servers. You can simply arrange to get capacity elastically as you need it. On-prem, you buy it and you own it, and that's it. So, in my opinion, there is no reason I can think of that you shouldn't move all of your decision support data out of this building and put it on some cloud platform somewhere else. So decision support should move first. You should do that now. I don't see any reason why not. Now, OLTP has lots of big problems, so it may move later or never, but at least get your decision support stuff out of this building. Now, whenever I tell people this, I get lots of yabbats. One of the yabbats I get turns out to come from the IT administration who runs an on-prem system for MIT CSAIL, which is my lab. And he said, the cloud is not cheaper. So this is the cost argument. Cloud is not cheaper. So I said, what makes you say that? He said, well, I don't pay for power and I don't pay for floor space. So basically, the economies are not accurate economics. So, yeah, he's cheating, or MIT is letting him cheat. So if you claim that your on-prem system is cheaper, chances are you're cheating. Lots of people complain about cloud security. In my opinion, the odds are that Amazon security is way better than your on-prem security. They take it really seriously. They pay more than minimum wage. And you remember remember what the big problems with on-prem systems are: misconfiguration, and then rogue employees. And rogue employees, you're not going to deal with by moving stuff out of this building, but misconfigurations you certainly will. Turn over running your decision support stuff to the people who do that for a living. Blunder number 2. I think this should be obvious to everybody. Machine learning is going to be disruptive in all kinds of places. And when I say machine learning, some of you say, well, do you mean deep learning or do you mean sort of conventional machine learning? And I say either one. It's going to be very disruptive. It's for sure going to displace workers with easy-to-explain jobs. Think autonomous vehicles, drone delivery, ... The odds that it is not disruptive in financial services is 0. So it's likely to be disruptive. So you have 2 choices in a disruptive world. You can be the disruptor or you can get disrupted. And so either you are Uber and Lyft and the other lookalikes, or you're the taxi business. You have to pick which one of those you are going to be. I would highly recommend you not be the taxi business. So plan on AI and machine learning to be disruptive. So what should you do? Well, the simple answer is pay up to get some expertise in this area. Now remember that they're in very short supply and very expensive, and Google gets first pick. So basically, simply pay up to get the best talent you have. And your HR people are not going to like what you have to pay, but simply do it. And for goodness sakes, don't hire Palantir to do this exercise for you. I'll come back to that in blunder number 8. So basically, there's going to be an arms race. Get going on it as quick as you can. And you will either be the winner or the loser in a winner takes most of it sweepstakes. So just recognize that this is where machine learning is going to take you. Blunder number 3. I hear a lot of people say, I'm really focused on data science. I hired a data science group. We have 30 people who are worried about data science algorithms, and we're on top of everything. So then I ask them the following question. How much time does your typical data scientist spend on finding the data he wants to analyze, cleaning it, and integrating it with other data sources? So the average answer I get is more than 90%. So your data scientist is spending 36 hours a week on this stuff and maybe 4 hours a week doing the job which you think you hired him for. So here are just 2 vignettes. iRobot is the guys who have the vacuum cleaners that run around your living room. I talked to a machine learning expert at iRobot, and here was her answer. She said, I spend 90% of my average week on data discovery, integration, and cleaning. That leaves me with 10% of my time. Of that 10%, I spend 90% fixing my data cleaning errors. That leaves me 1% for doing the job for which I was hired. Very, very typical answer. So you should all remember that your data scientists are not data scientists. That is not the job they're actually doing. They are in the data integration business. And so you might as well just admit that that's what your data scientists do. The chief data officer for Merck, the big drug guys, used to be a guy named Mark Schreiber. I asked him this question. He said, I have hundreds of data scientists. They average 95% of their time doing discovery, cleaning, and integration. So what should you do? It's pretty darn obvious. If you don't have clean data, or at least clean enough data, your data science is completely worthless. And so you've got to solve this problem. This is the high pole in the tent. And so the obvious directive to all of you is get a strategy in place to do this data munging. And for goodness sakes, your chief data officer, most of you have hired one by now. And I asked the chief data officer for GlaxoSmithKline, when he negotiated with his CEO, what was your first requirement? He said, read-only access to every piece of data GSK owns. So if your chief data officer doesn't have that, his possibility of helping fix this is kind of low. So start by giving your CDO access to all enterprise data. And you might ask the question, well, suppose the CEO won't do that. Well, that comes up in blunder number 11, which we'll end with. So empower your data scientists to realize that they are in the data integration business. So then you say, well, how do I do data integration? Loosely speaking, this is discovery, cleaning, integrating multiple data sources. So the blunder that a lot of you make is that belief that the traditional solutions will solve this problem for you. So first thing that was invented in the 90s was what's called extract, transform, and load, available from a variety of vendors. So that says that I have a bunch of data sources all over the place. First, I have to extract the data. Then I have to move it to a central place. And then I have to load it into a data warehouse. So this was invented as a data warehouse loading system. So this was the first technology. And everybody says, well, I know how to do ETL, I'm golden. And the next slide will say, no, you're not. And then more recently in the 2000s, the same vendors started to bring you what's called master data management. And so many of you have a belief that these two technologies will solve your data integration problems. And let's first look at ETL. So what the ETL vendors all say is, what I need you to do is, I'm going to decide in advance that here are 47 data sources. I want you to integrate them. So that comes from God. God, meaning your smartest technical person, builds a global data model up front for these 47 sources. And then you send out 47 programmers to the business owners of these various data sources, one by one by one. Have him interview the data source owner, figure out exactly what's in that data source, figure out how to scrape it, and figure out how to transform it into whatever the schema that you've upfront decided is. So that's ETL, and that's the way the traditional vendors' products work. So here's why it doesn't work. I've seen a lot of people who use this to load data warehouses, and my first question to them is, how many data sources are you loading? And you don't get to count that I have 20 exact replicas of the same data. You can't count that as 20, you have to count it as 1. So the average answer I get is less than 10. I've rarely heard a number in the 20-ish range, and you twist my arm hard and I'll give you 50. But this is a human-intensive world, And it takes a lot of time, and it just gets too expensive when you try and do this at scale. Second problem with ETL is you got to have a global data model up front. And you guys all tried building enterprise-wide data models in the 90s. Every single project failed. And the reason was you sent a team of 4 or 5 people out to try and collect all this information. They took 2 years to do it. They came back and said, well, here's my global data model. And it was accurate as of 2 years ago, and since then the business has moved on. So none of you have managed to make this work, and there's no reason to believe that this will ever work at scale, because your enterprises are too agile. And so most enterprises I know of are interested in integrating way more than 20 data sources. Why do I say that? Well, I talk to people who want to do this. My favorite example is Novartis. Novartis has, round numbers, 10,000 biologists and chemists doing wet stuff in the lab and writing down results in, think of them as electronic lab notebooks. Novartis wants to integrate 10,000 lab notebooks. Why do they want to do that? Well, if you're a scientist in Basel and you're producing GUK-A, and I'm a scientist in Cambridge and I'm producing GUK-A, you want to do social networking so we can talk to each other. And Novartis is distributed all over the world. So most everybody I know wants to do more than 20 data sources, and this technology is brittle. It's just not going to scale. So if you believe this is going to work and you've got less than 20 data sources, have at it. Be my guest. If you have a bigger problem that you want to solve, and most everybody I know does, then this is brittle technology. It's going to fail almost for sure. What about master data management? Well, once you get everything into the same place, then you've got to do match merge. Well, what do I mean by that? Well, if the 2 Novartis guys are both producing GUK-A, you've got to figure out that GUK-A means GUK-A because people will talk about it using, different vocabulary. So you've got to match records to figure out which ones actually go together, so-called entity consolidation. And then once you get a whole bunch of these records, lots of times you want to produce what are called golden records that are single records that characterize this particular stuff, GUK-A. So how does the MDM guys suggest you do match and merge? The answer is they suggest using rule systems. So, for example, 2 entities are the same if they have the same address, would be a reasonable rule. And so you write a whole bunch of these rules. Merge rules are the same thing. I have a bunch of salaries that purport to being for Mike Stonebreaker. Take the most recent one. So you write a bunch of rules. Trouble is, rule systems do not scale. Small problems, have at it. Big problems, this technology fails. So I'll just give you one very simple example. GE, which is a Tamer customer that you can hear about later on today, they want to classify 20 million spend transactions into a predefined taxonomy. So how did they do that? Well, they drank the traditional Kool-Aid, and they started writing some rules. So they wrote 500 of them, which is about as big a rule set as you or I can actually get our brains around. That classified 10% of their spend transactions. That got you 2 million. You now have 18 million to go. They figured out they had little chance of quickly building 5,000 plus rules to actually use this technology at scale. So the problem with rule systems is they don't scale because you need too many of them when the problem gets big. So what in the world did GE do? Well, they had a partnership with Tamer, and Tamer does data integration using machine learning. And so Tamer used their 500 rules to produce 2 million training records, built a machine learning model which classified the remaining 18 million, worked like a charm. So ML is going to take over in this space, and rule systems are not the right answer. They're great for training data, but don't try and use it on big problems. Okay, blunder number 5. This usually comes from warehouse administrators. They say, I have the world's best data warehouse. We're doing great. We've cleaned the data. ETL is working like a charm. And just realize that this solves a piece of the problem that you want to solve, a piece of your big data problem. And by all means, use your data warehouse for what it's good for, which is customer-facing structured data from a few data sources. Don't try and put text and image and video into your data warehouse. Do not try and perform unnatural acts, which is glue a graph database into your warehouse. Use the warehouse for what it's good for. And by and large, your warehouse is going to move to the cloud, remember? So when you move it, make sure you get rid of the high-priced spread. Because a lot of you have bought into traditional data warehouse technology that costs you 7 figures a year. There's no reason why you should pay for that stuff. It doesn't work very well. So if you bought into one of the traditional vendors that's raping you, get rid of the high price spread. And just remember always that your warehouse is going to move to the cloud. And the sooner you do that, the better off you are. Okay. Essentially, all of you drank the Hadoop Spark Kool-Aid. And I heard this all the time, starting around 2011, 8 years ago. Google says Hadoop is the answer. Hadoop, by the way, means MapReduce, the open source version of it written by Yahoo. MapReduce. And MapReduce is not good for anything. I can state that categorically. And for that matter, Spark is not particularly competitive at anything. Spark SQL is not very good. Spark Streaming is not very good. So, in my opinion, you should be looking at best-of-breed technologies, not lowest common denominator, at least for your secret sauce. And it seems to me the universal blunder you guys all make is I only want to deal with Oracle. Oracle is the answer. Now, what was the question? Well, the trouble is Oracle, there are a lot of things that it's good at, but it's not good at everything. And if you want to stamp out everything else, I think you're doing yourself a disservice, especially for your whatever your secret sauce is. And for that matter, Spark and Hadoop are useless on doing data integration. They have no capability in that area. And that's what your data scientists are spending all their time on. And so I think belief that Hadoop and Spark will solve all your problems is often put forth by your Hadoop administrator. But just remember, it's simply not true that technology is not very good at much of anything. So then you said, well, we drank the Google Kool-Aid in 2011, and we now own a 1,000-node Hadoop cluster, and we're spending a fortune on Cloudera or Hortonworks or whoever to keep this up. So what do you do with your Hadoop cluster? And I've heard this from a lot of users. They say no one wants to use Hadoop. or no one wants to use MapReduce. And so what do I do with my MapReduce cluster? The answer is repurpose it for something else. We'll talk in a minute about data lakes. So repurpose it for your data lake. That'd be fine. Repurpose it for doing data integration. That is your big problem, in my opinion. If you're going to take on doing data integration in a serious way, this would be a resource to do it. Third answer is throw it away. Hardware has a 3-year, you should be writing off hardware over, say, 3 years, and throw it away. Move to the cloud. So remember blunder number 1. Okay, so then you say, wow, I drank the Kool-Aid. Data lakes is the new way to talk about Hadoop Spark clusters. And so the conventional wisdom is I'm just going to load all my data into a data lake, and that way I can correlate everything. Life is great. I'm on it. If you don't take away anything else from this talk, tattoo this on your brain. Independently constructed databases are never plug compatible. Never. They do not have the same schema. They simply don't, because you think about things differently than I do. So if you dump all your stuff in one place, you get a whole bunch of data sets that don't have the same schema. Why don't they? You call it salary, I call it wages. If you're the HR person in Paris, I'm the HR person in New York. You deal in euros, I deal in dollars. The semantics don't match, which is salaries in Paris, they are in euros, they are net after taxes and include a government-mandated lunch allowance. In the US, it's gross before taxes, no lunch allowance. You simply line up these salaries and they're not comparable. So the semantics don't match. Time granularity as often as not doesn't match. You have annual data, I have monthly data, et cetera, et cetera. If I line up 2 databases, chances are 10% of that data is wrong or missing. So I see any number of databases where minus 99 doesn't mean negative 99, it means null. And you simply, whatever software you're using didn't have a support for null or whatever. So the data is dirty. And if you don't clean it, you're toast. Other problem which you shouldn't underestimate is that if you're the HR Paris person, I'm the HR New York person, what about employees that work for both places? If you just add up the number of records you have with the number I have, you're going to overcount by the number of duplicates. So you say, well, gee, is that really a problem? Well, Tamer has a customer that was using this to count up suppliers, and they were overcounting suppliers by a factor of 2 by using just add up the numbers in the various databases. So you've got to remove the duplicates or you're going to make serious errors. So if you don't deal with this stuff, your analytics will be complete garbage. And so garbage in, garbage out. And your ML models will fail, your data science analyses will fail. And so you can't get away from dealing with this stuff. And you guys all decompose into independent business units so you can get stuff done. Independent business units produce schemas that are not plug compatible with each other. You want to do cross business unit stuff, you get this problem, and you get it in spades. So what to do? You don't have a data lake, you have a data swamp. Pardon my, and your problem is to clean the swamp. So you need a data curation system, And most of you don't realize that this is what you need. You need a way at scale to turn your data swamp into a data lake. And this is not going to be trivial. You've got to solve all the problems on the previous slide. And this is an 800-pound gorilla. This problem has been around ever since I've been an adult. And it's getting easier by applying machine learning and modern techniques. But it still is not going to be easy. Put your best people on it, because otherwise you hire 1,000 data scientists, they're going to spend 1 hour a week doing data science, and the remaining 39 hours a week in an ad hoc way solving this stuff. So solve it in a more systematic way. If you have an in-house data integration solution, chances are it's crap, because chances are it's 10 years old. And if it doesn't use machine learning, chances are it's crap. So use modern technology, and it comes from startups. If you want to be technologically ahead and leverage this new stuff, it's mostly coming from startups. People in the other room are all startups. So don't use your homebrew system. And if you want the best technology, you've got to deal with startups. If you don't want the best technology, you're going to get overrun by your competitors. Okay. I hear lots of people saying, well, I hired Palantir to look at this, or Mu Sigma or IBM or whoever your favorite consultant is. So most of you guys, when I ask you what percentage of your IT budget do you spend just keeping the lights on, keeping your current stuff running, most of you say at least 95%. So 5% is left for new stuff. Most of you are dug in pretty deep into legacy systems, some of which you don't even have the source code for. So the shiny new stuff gets outsourced, often because there's no one appropriate to work on it, or because your best people are stuck keeping your accounts receivable system up. So if you do this, this is a really, really bad outcome. Your maintenance is boring. I hear a lot of you tell me what you do day to day, and it's boring. I don't want to do it. So your creative people quit. And if you don't have any good talent, then you don't have talent to work on the new stuff. And if you don't have good talent, it's hard to hire good talent, because great people hire great people. Okay people hire crummy people. So your new stuff is going to be your secret sauce over the next decade or two. Please don't outsource it. You outsource it to Palantir, then your competitor also pretty much gets schooled on whatever Palantir is going to do. So this is long-term suicide. So outsource your diddly crap. For God's sakes, don't run your own email system. That is just diddly crap. And software is your secret sauce. Invest in your own people. Otherwise, long-term, you're going to lose. So what to do in this area? Well, start by solving blunder number 2. You've got to have AI, ML expertise in-house, and outsource your boring maintenance, and for God's sakes, get rid of your Palantir contract. Okay, succumbing to the innovator's dilemma. You guys are dug in pretty deep into legacy systems. There's a fantastic book, which is now a decade old or so, called The Innovator's Dilemma by a Harvard Business School professor named Clayton Christensen. I don't have time to talk about it, but the thesis of this book is that it's very hard to switch from the old stuff to the new stuff without losing some of your current customers. And read the book, because I just don't have time to talk about it, but read the book. Net is that the new stuff is coming at you in a big way. You can either believe in blockchain or not, but in my opinion, that's the wrong thing to bet on. But you have to make all kinds of bets on the future. And a bunch of them are going to require you to give up at least some piece of your current business model and reinvent yourself. And you simply have to be willing to do that in any high-tech field. Otherwise, in the long run, you're going to go out of business. So I just want to remind you that in the city of Cambridge, where MIT is, the value of a taxi medallion has gone from $700,000 to less than $10,000 in a decade. So just remember that. Okay, blunder number 10. Hire a few rocket scientists. You have to worry about all this stuff, and none of it is trivial. So hire a few rocket scientists. They will be your guiding light. And they'll be way off scale, and they're going to be weird. And please don't drive them away. They're not going to wear suits, so forget that. So pay up for a few rocket scientists to help you with this class of problems. And then, of course, my bonus blunder is that as a result of this talk, I get a lot of questions like, my company won't ever do any of this. And my answer to that is, well, then you're working for the wrong company. So you're either part of the solution or you're part of the problem. So you should either be fixing stuff or looking for a new employer. And by the way, Tamer's hiring. So that's the end of my slides with a little luck. I'm sure I've made somebody mad by now. What do I think is the replacement for ETL and MDM? MDM is machine learning. Rules can be training data for a machine learning system. ETL, my favorite example is GSK. So GSK wishes to integrate all of their research data. That is more than 10 million attributes and more than 1 million tables. So ETL is hopeless at anything like this. So what's the answer? The answer is machine learning. So take your 1 million tables, classify them into things that look like they're the same kind of stuff, do that using machine learning, then deduplicate the tables using machine learning. The answer is machine learning. At scale, nothing else is going to work. Okay, do I believe in the private cloud or the public cloud? That's completely an economic question. So the public cloud, you can go look at how much it's going to cost you. You can figure out what your workload is, what your elasticity requirements are, et cetera, et cetera, et cetera. You can negotiate with Microsoft, Google, Amazon, Oracle, IBM, anybody who runs the cloud. Do whichever is cheaper. I mean, I think a private cloud is simply a bunch of machines in a Google data center, or you can be spread across Google's other machines. I don't see that technically it makes a whole lot of difference. Anyway, it's a question. Basically, it's an economic question. Hadoop, Spark are not the right technologies. What are good alternatives? Well, Hadoop, meaning map reduce, is not good for anything. Spark is mostly an analytics system. There are a ton of platforms to do analysis, and more coming out of the woodwork every day. You're going to have to pick some sort of analytic platform because there's going to be a lot of useful tools. And unlike the internet where there's only one answer, in the world of analytic platforms, there's 20 answers. Look around and choose the best one. And your kitchen cabinet of incredibly bright computer scientists, hire that team and tell them to pick. What companies are getting their in-house data science right? I think GSK is doing very well. So go look at GlaxoSmithKline. So I think that's my favorite exemplar. I think depending on actually what I would really do is your data science problem is a data integration problem. It's not a data science problem. So who's doing data integration correctly at scale? I would go ask the Tamer guys who in the kind of business that I do is doing the best job at data integration. So go to their talk. Regarding cloud services, what are the risks of data loss? The answer is lower than if you do it in-house. They are simply better at not losing your data than you are. So the answer is there is a risk. Bad things do happen. And you have to decide, do I want to wear a belt? Do I want to wear a belt plus suspenders? Do I want a belt plus suspenders plus a hook? And how much do you want to spend in order to guarantee that you're never going to lose your data? And that's a serious technical question that is an economic one. So I love Dave Clark's money routing. These are money routing questions. Do you see graph technology solving most blunders? I think graph databases is a thing right up there with blockchain as something that people love. Graph databases so far, the commercial offerings are generally no good, which means they are beaten by a relational simulation of a graph, meaning an edge table and a node table. They're beaten by array databases, again, an edge array and a node array. So far, there's no particular benefit to running a specialized graph database. As far as semantically, whether you want to view your data as a graph, for sure, if that's what floats your boat, that's a data model question. Do I get to stop now?